Fingers.
Hello, everyone. Hello, and welcome to the next episode of CyberJar live streams. Today, in my studio, I have Rogerio Robetti, the founder of Open J Proxy. Rogerio has already visited our live stream, so it's becoming a very good tradition. I think so. Hello, Rogerio.
Hello. Thanks
How
for
are
having
you
me
today?
again. I'm very good. It's always a pleasure to be here.
Yeah, thank you for coming. Friends, we are going to discuss today a very relevant topic related to the performance of Java applications. But this problem that we are going to discuss may be very insidious. Remember the movie Insidious? So you may think that the problem is in slow queries or in failing database, but actually this problem lays deeper, right, in the application code. So today we are talking about JDBC connection pooling problem. And if you have any questions or you just want to say hi, just jump straight into the chat and we will be happy to answer any of your questions. So, Rogerio, are we ready to dig into this hole?
Absolutely, yeah. Just before we start, Catherine, if you allow me, just to say a few words. First of all, thank you for having me here again. I think the CyberJar brings relevant topics to the Java community. I fell in love with the channel as soon as I started following it. It changed my mind, and I'm quite stubborn in relation to some subjects due to the quality of the content that the channel always delivers. And for me, it's a privilege to be speaking here. And if the guys that are watching are not subscribed yet, hit the like, hit the subscribe button, follow CyberJar. You're going to be a better developer by doing that. And thanks again for having me here. But absolutely, yeah, let's dig into it.
Right. Thank you. Thank you very much for your kind words. And it's a great pleasure to have you here as a guest for the second time. And yeah, maybe it will become a very nice tradition. So we always discuss some very interesting topics related to JDBC, to connections to the database. And the database is, well, the heart, right, of most applications, because most applications somehow work with data. And as I already said in the beginning, the problem that you may experience with the performance of applications may be related to JDBC connection pools. But first, Rogerio, can you please describe to us the symptoms that developers or engineers may see in their logs or in their metrics that might lead us to JDBC connection pool? So what kind of symptoms do we see?
Yeah, I think the most when you start seeing like timeouts in your logs or failure to acquire connections, right, that might be related to a connection pool issue. In general, when we look at connection pools, we expect them to borrow connections, give it back the connections. You made a wonderful video recently about it. And the thing is that our architecture design evolved in a way that put more pressure into connection pools. And but in relation to how we see it in applications, is a slow degradation in response time. That's one thing, right? In your metrics, you're going to start seeing the average query times decreasing, and you might start seeing timeouts. And in the worst case scenario, your database may be rendered unresponsive altogether. And that normally can be caused by two different situations. We can talk about both of them. One is a legitimate increase in demand in modern applications, right? You have a Black Friday or something that largely increases your demand and the demand for the connection pool. Or you can be under a DOS attack. And that's something I think we need to talk a bit as well, because a sudden increase in demand is not always a legitimate increase in demand. And it might be a DOS attack, and you need to be prepared for that as well.
So is this the problem that is typical for microservices only?
Very good question. It became more apparent in microservices. I think it's good for us to make a little bit of a history path of connection pools. Connection pools is not a new thing, right? It's being created long ago. As soon as we started using relational databases, we started using connection pools. And the rationale to do that is that establishing a connection is something that's expensive, right? You need to do the initial connection, you need to do the validation of the certificates, the handshakes. So until you establish that ELS or SSL secure connection, it's an expensive process. So if you keep opening and closing connections, that is not ideal. And that's how we came about the idea of using connection pools, right? It was not a new idea. It was we used pools in other resources, and it became dominant. But that was fine when we were using monolith applications, right? Because monolith applications, you have 1, 2, 3 instances, very large instances of one application. But as our mindset evolved into microservices and lambdas, this shifted quite dramatically, because if you think about it, in the old days, I used to work with applications that would be one big server, one failover server, right? It was a very common scenario. Very large servers like WebLogic, WebSphere, application servers. And that was very easy in quotes, right? But it was simpler to manage the connection pool because you have just one application. Let's say if you set that application to have 50 connections to the database maximum, that will be respected, right? Because you have only one application, and if that fails, you go to the failover, which also only opens 50 connections. But as we transit into microservices, that especially the ones deployed in Kubernetes and other orchestrators that can go down and up, very dynamically, that shifted substantially because now we have one connection pool per application node. But these nodes can die at any moment. They can be replaced by Kubernetes. And that, from the connection pool perspective, becomes a problem because it's not the same scenario as before that we have full control, a single instance of the application, and it's easy to set a limit. Nowadays, it's harder to set a limit because you have these pods or instances of your application coming up and down due to the orchestration, which is a good thing, right? Because it gives us the ability to elastic scale or descale our applications. But it brings this challenge in terms of architecture, which is how can we coordinate this scaling with the numbers in the connection pool? Because obviously, if you're putting more pods, you're creating more connection pools, you're putting more pressure in the database at the end of the day. So that's a mismatch or an impedance mismatch, I think is a term that people like to use in relation to the architecture we moved into, like microservices, more segregated architectures, lambdas, and the centralized kind of limited resource, which is the connections to the database, because the database is a stateful system. It's not a system that you can easily scale. So we need to treat a connection pool as a limited resource and a shared resource. So that's the mismatch there. Like you have these connection pools being spinned up everywhere, but you actually want to treat them as a centralized and limited pool of resources.
Interesting. But how do we actually know that the problem is the connection pool and not the slow query? How do we distinguish between these two?
Very good question. In general, we know that by monitoring the times of the queries, right? Like there are two problems. I think one doesn't eliminate the other. I think that's the first thing to make clear. One thing is if you have slow queries, you need to be careful when they run. I think that's the most important thing. Like if you have reporting queries, like when can they run, against which database they run, so they will put pressure in the database. Now, another thing that puts pressure in the database is the amount of parallel connections you have against this database. Because the database is more performant, actually, if you can serialize work to it more. And that's because if you think about when a database will do a simple operation, simple update operation, it needs to handle the locking of the rows that you want to update, right? But if you have too many threads trying to update the same things, that creates contention. And that contention, the database will deal with it, right? It's well prepared to deal with it, but it will spend resources to deal with it, right? To switch context between these threads, and when I say threads, between these connections, right? At the end of the day, each connection is a tunnel to the database. And in relation to the slow queries, like there are two problems. One is if you have slow, potentially badly written queries hitting your database, that is a problem. If you have your database already under stress and you hit it with these slow queries, it will increase the problem. And another thing is, if you have your database under stress and you increase the number of connections suddenly against it, which we call it a connection storm, right? Or you have multiple nodes being restarted or replaced by the orchestrator, that will create extra pressure. So that's the things you need to be careful when you're creating or analyzing your solution for connection pools.
Mm-hmm. So what is the best approach then to configure the connection pool? Or is there even a better alternative to JDBC connection pools to solve these issues?
Yes and no. So I'm the founder of OJP, right? So I'll be advocating for the OJP. But before we go into OJP and what is different, I think the solution that came about is the database proxies, right? So we have Amazon AWS RDS proxy, we have PG Pool proxy, PG Bouncer, Proxy SQL, Oracle Synapse. So the solution found by engineers was to create a proxy, right? So instead of you having your connection pool into your application code, you externalize it. You put a server there that will be a proxy to the database. So you don't hit the database directly anymore. You hit this proxy, and this proxy will control the connection pool. And that gives you a lot of advantages, right? Like you eliminate these connection storms. Now you have a centralized place to control your connections, but you pay a cost of an extra round trip in the network, right? And that's a bit of a problem in relation to this. Another problem you have is usually the proxies, they are bound to one database or to one cloud provider. So not all of them are open source. Like you have proprietary solutions like the Amazon AWS proxy that they are closed, right? They are made for the AWS solutions, and they work well with AWS solutions. But also, I think in modern architectures, we are looking for solutions that we can transit between clouds more easily. So let's say Kubernetes became a very proeminent example of this, because before Kubernetes, you had to do things differently in every cloud. Basically, it was the AWS, right? AWS dominated the cloud industry, but basically you had to do everything how AWS tell you to do. And once you are in there, it reminds me the lock-in we had with application servers. Like you would develop an application for WebSphere, it wouldn't run in WebLogic or in Tomcat. You couldn't port it. So I think there is a movement happening, which is a search by engineers and architects for solutions that are portable between clouds. So the solutions that are bound to one cloud or to one database, they cost you, right? Because it basically tied you up with a single solution.
Of course. Yeah.
Yeah.
So sorry for interrupting you, but
No,
I
no.
agree. So what most teams need and are looking for is the agnosticism in the tool, right? So it has to be database agnostic, cloud agnostic, right? So we don't want the vendor lock, right? It is possible, of course, it's your if your whole infrastructure is based on the solutions by one vendor, and you are satisfied with that, well, that's okay, of course, that's also a path to go. But if you're looking for more flexibility, then you don't want to depend on the vendor, right? Because in this case, there's also a risk that the vendor that you depend on changes the rules of the game, right? And then you might be in a very undesirable situation, right? So agnostic tools, as I call them, they help you to use the advantages that this vendor provides you. But if you are then dissatisfied with what vendor does, you can switch, right, to another provider. You can go wherever and do whatever, and your whole infrastructure is not going to be broken. But before we go into discussing the database proxies, there's one more question that I wanted to ask, and it might be a disclaimer even. So, if is the database proxy the perfect solution? If we integrate the database proxy into our infrastructure, does it mean that we solved our problems and we don't have to think about connection pools, about slow queries? Does the proxy solve all issues for us and we don't have to care about anything else?
No, like we still have problems, right? Like, and we do create a new set of problems, right? But I think the proxy solves the core issue, which is the discrepancy between the monolithic versus microservices or more granular architectures. And more granular can be the microservices, the event-driven architectures, or Lambda architectures, right? Because they have many more pods, many more or functions or listeners to the event, right? And you need connections everywhere. And most of systems, like I know we've been talking a lot about using multiple databases, being agnostic about database, but the reality of the the field is that most of applications still rely on relational database, right? So we still need to deal with this contention. So I think that it is valuable to think about a proxy as a solution, especially if you are thinking about growing, right? I think that the main use case where you don't need to think about this at all is if you're small. Let's say you're developing a system that is for like a university campus, or that your number of users will never grow out of the hundreds or thousands max. Then I think it's detrimental even to put the complexity of a database pool or proxy into your engineering roadmap. But that's I think that's the only downsides of it. Like obviously there is a bit more engineering involved, but I think the upsides in relation to modern architectures and to the ability to scale more safely, they are very important to be looked into.
Of course, over complexity kills, really, right? And some applications don't even need the microservices architecture, right? Some applications are quite well being the monoliths, right? We don't have to migrate to microservices if the application is small and we are not going to grow, as you rightfully mentioned, more than like a couple of thousands of users. But yeah, if we do have this constellation of microservices and we want to scale safely, how does the database proxy sitting in between the application and the database, or in between the services, microservices, and the database, helps to achieve this efficient scaling?
I think the first immediate benefit you see is that you set the max number of connections to the database. That's a very important number. If you talk to DBAs, like one of the first things they want to guarantee is that the maximum concurrency level will be respected, right? And if you're doing microservices without some sort of solution like a proxy or something, it's very hard to guarantee that, because it's very hard to measure, like, especially if you have a large scalability. which is, let's say your microservice can grow from 5 to 20 instances. So it can grow quite a lot. So how are you going to distribute those connections? If you don't have a proxy that centralizes it, and there is no other real solution for this at the moment, not that I know about, except the proxy. How can you coordinate that? Will you implement some sort of a cluster in your application? But then your application is no longer stateless, right? And we want stateless applications so we can kill them, restart them without much trouble. So the immediate benefit of the proxy is you centralize the control of the connections. That creates what we call immediate back pressure. What is that? Back pressure doesn't matter how much inflow is coming, the proxy will hold that pressure in itself and will not let that pressure get to the database. And I think there is where we start seeing the benefits, because you see, if we allowed that pressure to hit the database, and we talked about slow queries, and sometimes all you need is 2 or 3 bad things to happen together to create a chaos, right? You have your database under stress, a slow query comes in, and a new pod in Kubernetes is provisioned that wants 10 new connections to the database and wants to hammer those 10 connections, right, with requests. And then you're receiving a call 3 in the morning, right, because the database is unresponsive.
Yeah.
Unresponsive. So I think the immediate benefits is that ability to control the pressure to the database and to back pressure it to the proxy.
But what if can it happen that the proxy itself is overwhelmed by the multiple connections that services require?
Yes, it's possible, but it's a lot less likely, right? Because the job of the proxy is much lighter than the database. The database, as we mentioned before, needs to manage locking, needs to manage indexing, needs to keep ACID guarantees. So it's a lot of work really, and needs to work with disks, right? It needs to write in disk. A proxy mostly works in memory and with a lot less information. So it's mostly a pass-through. So it's a much simpler piece of technology. So to be able to overwhelm a proxy is a lot harder to overwhelm the database, because the proxy can take a lot more parallelism, for example, because it's not doing anything else. That's its job. The big difference is the database job is not to handle multi-parallelism, large multi-parallelism. The job of the database, the main job, is to store data and retrieve data for you. And once you get the database to be handling all these multiple connections and excessive connections especially, it's doing a job that doesn't help its main goal of storing and retrieving information safely. So when you outsource this to the proxy can be overwhelmed, but the proxy is a lot easier to scale. And I think that's the main thing that is beneficial to have it. It's a lot easier for you to put 3, 5, 6, 7 proxy instances than databases, because the database, generally, you're going to have one primary database, and that's the one you write your data and where you send your transactions to. And then you might have a few read replicas, right? That you can read data that can or not be a bit, delayed on the time. So that's the general separation we can do, but it's not that flexible in relation to how many instances you can put. Like in general, you grow your database scaling vertically, right? Not horizontally. The proxy allows you to grow more horizontally, allows you to take a lot of more parallel requests, and can organize these requests into a series of requests to the database. So allowing the database only to be concerned about the job of storing and retrieving data.
That's great. That sounds awesome. So this way we can really increase this resilience, the database resilience, right? And prevent the situations when it just exits because it's like super overwhelmed. But there are always trade-offs, right? There's nothing perfect in this world, unfortunately, or maybe fortunately. So that's
Unfortunately,
well, yeah. Does the proxy introduce any, if any, overhead per query or per one round trip to the database? Does it increase the latency?
It does. It does. Absolutely, it does. It also depends where you put the proxy, right? Because there are basically 3 places you can put the proxy. In general, in production environments, you're going to have one network section for the application and a different network section protected by a firewall to the database. So you can put the proxy on the side of the application. So it will be very fast for the application to reach the proxy, but it will be a bit slower from the proxy to the database. So you have a new node in your route to the database. And I want to say one node, but it's actually 2 nodes. And I explain why. When you have the traditional proxies, and that's not OJP. OJP does it differently, and I'll explain what's different. So traditional proxies, the way to scale traditional proxies is by putting a load balancer in front of the proxy. So you get 2 more hoops before you reach the database. And that's one of the reasons why some architects don't like the idea of using a proxy, because it's already a problem to put 1 more hoop in the network, right? Because in the normal requests, you're losing that millisecond, 2 milliseconds. That depends where it is, right? It could be even more, but like in general, 1-2 milliseconds to do an extra round trip to the proxy. Then you need to put another one because you need a load balancer in front of the proxy. Or you don't put a load balancer, but then you have a single proxy. And is that something you want in your architecture? Like you have a single point of failure? It's quite risky. Many people wouldn't be comfortable doing that. So the trade-off there is, like, in general, if you go for a proxy, a traditional proxy, not OJP, you're gonna probably need to put a load balancer in front of it to make it scale. There is another problem that I find very important, which is AWS disclose partially how they handle the scaling of their proxy. For me, that's an issue. I want to know what they're doing. I want to know how it's done, because I cannot, I don't like trusting magic. Engineering is not magic. So I want to know how they are scaling these pods exactly, what triggers they scale, and especially what can affect my application, right? How long does it take to scale? Like, because let's say it's putting a load balancer in front, it's not clear in their documentation. If at least not, I couldn't find. If someone in the video has the documentation, please send. I'd be glad to read. But sometimes in these closed solutions, what I've seen is that there is a lot of marketing and a lot of we do magic, but it's not clear how the magic is done. And usually it's when it's not clear, it hints me the idea that maybe it's not as great as it sounds, and it puts this load balancer, but they don't want to really talk about it, in front. So in OJP, we did it differently because we provide the proxy and a JDBC type 3 driver. We can do the load balancing in the driver. So we eliminate the need of an external load balancer, and we find it very important because it reduces that round trip. You still have an extra round trip, right? So that's the cost. Every decision you make in engineering or in life, right, has a cost and a reward. So everything we talked about, good things that a proxy brings, the cost is this round trip. There is an extra round trip to the proxy. Now, we did some performance testing in Open J Proxy, and what we notice is that even with low concurrency, let's say 100 users, that latency goes away because you remove so much pressure from the database, from the parallelism, that it compensates the round trip, and queries actually look faster under pressure. One query will never be faster, right? 1 or 10 queries, but when you start talking about hundreds hitting the database at the same time, a proxy might actually improve your latency, which sounds counterintuitive, but it's because it can do this decreasing this parallelism to the database, and the database uses less resources for managing things, and uses more resources to actually deliver work. So that's I think that's a very important part of when you're looking at the proxy. Like, it does cost, right? And in normal conditions, whenever your system is not under pressure, it's not when you see the value of the proxy. It's when you're under stress, when it's about to die, then the proxy shines, because it's where it protects the database, where it shields the database against that pressure.
Well, you said that, and I just thought that database proxy is like the insurance that you buy, right? In normal times, you buy the insurance, and well, you don't need that, and then you doubt maybe I shouldn't have bought that. But when the problem hits, right, that's when it comes. That's when it becomes important whether you have the insurance or not, right? And if you don't have it and you have the problem, then nobody is going to sell you the insurance, right? So
Exactly.
maybe the same was, yeah, with the database proxy. That's nice. I like this comparison.
It's a very good comparison. Yeah, I couldn't have done better myself. Is exactly what you said. You see it more under stress, right? And
Yeah,
that brought another part that, if you allow me to bring to this discussion,
of
is
course.
the part that, in general, like the setups over provision the database because of that. Because you see, you need to provision a database that's capable of taking the very maximum amount of concurrency you can tolerate, right? And in many places, that means the database is over provisioned. And you have that cost all year round. Let's say that over provisioned database is only necessary for 10 or 5% of your trading time. But as we said before, like scaling the scaling database is not that easy. And like I know some clouds claim that they do it like automatically. Whenever they say that, is again like the magic that is not well explained. Like, to be able to scale fast a database, you need to have a warm node. What does that mean? You need to have the node synchronized with the data of the previous node. So if they have that warm node, they are charging you for that, right? So
Of
if they
course.
have a warm node to put in a cluster, they're charging you for that. So this drives the costs of applications up. In general, applications are running with a database that they didn't have to have. And if they adopted a solution like a database proxy, like OJP, they could reduce those costs, because if you have only 5% of the time these surges in demand, the proxy can accommodate that demand. It will be a bit slower than having the over-provisioned database, but maybe still in your SLAs, right? And that's what matters to the customer. Because when we say it degrades, how much does it degrade? Because that's the question. You might be well under your SLAs in terms of how many seconds it takes for a customer to finish an order. And that even though your times degraded a bit, the proxy allowed you to have a database that is cheaper all year round. And that includes databases that are provisioned in clouds, right? Like managed clouds, or databases that are proprietary, that you pay by CPU, right? There is still agreements that are CPU based, right? And if the
Yeah.
database is doing anything else than storing data, retrieving data, and doing the guarantees of ACID transactions, that's cost for you. So I think the idea of putting a proxy helps you to be able to decrease the database you're using and saving costs. I think at the end of the day, it improves the reliability of your system for sure. It does increase the latency when you're not under stress, and it probably will help you to decrease the costs of your database instances.
That's a very interesting point. I didn't even think about that at first, that by using a database proxy in the right way, we can actually decrease the cloud costs, which may rise up to the heavens. So the cloud bills sometimes are just huge because we have to over provision, right? It's not only about the database, but also about our regular nodes. I mean, I remember this issue was and still is discussed very much around Java, right? Because Java services take time to start and they take time to warm up, right? And it may take from several seconds to several minutes. So using serverless functions like lambdas with Java, that's almost impossible, right? Because we just can't scale up and scale down Java rapidly. Maybe the same goes for the database, right? But Rogerio, you mentioned that Open J Proxy
Just
is
one
based
note,
on.
that there are very good videos here in the channel about how you can speed up startup times. So if there is ways to speed up Java to startup times here in the channel. So look for the
Oh
videos.
yeah, that is just yeah. Thank you for mentioning that. So this is my area of expertise, I would say. So I've been doing several talks and published several articles on ways to increase the startup time of Java, with native image, with AOT cache. And just this moment I thought, is it possible to put data? Oh no, maybe that's going to be useless, because you don't have to like spin up database up and down. It just works, right? That's what we discussed. It just a long term.
I would say the database is spin up time. Well, it is relevant because, for example, we at the OJP, we support 7 different databases, right? And the proprietary ones we support is Oracle, SQL Server, and DB2. And DB2 takes forever to start. It really takes like, I think it's 15 minutes to start the Docker image that we use to test. And why is that? Because you don't really restart it, right? So when it starts, it loads a lot of things. It's the kind of a, or not old, but the traditional mentality that you shouldn't be restarting these servers, right? But the database, the biggest cost in the database provisioning is not the startup itself, except for DB2, which takes forever to start. But but as I said, in the places where DB2 runs, it doesn't need to be restarted often, right? It usually runs close to mainframes, close to traditional architectures that you don't restart. You restart a few times a year, these databases, right? So it's not really a problem. Yeah. The problem I see by provisioning new nodes of databases, moving data, right? Especially if you have a large database. Like, let's say you have terabytes of data to move between servers. Let's not talk about like, oh, I have a common folder that I can point a new instance to that share the location and share the disk space. No, if you really need to move data, that becomes the problem, because it takes a long time. Even with the modern networks, you cannot have, and when I say long time, you cannot do the elastic scale like we do for our microservices. That's what I mean. Because the microservices are mostly stateless if they're well designed, and we can kill them and bring them up quite easily. So in the database, I would say there are reasons to work on improving speed up on startup time. Like, for example, if DB2 wants to compete more in environments where it's more dynamic, how frequently you start up the database, probably they should think of a linear version that's speeding up faster. But the biggest cost, I would say, is to move data. And in relation to speeding up Java applications, I think there is a lot of ground being covered. I think new frameworks like Quarkus does it a little bit better than standard Spring Boot. I think I might be wrong here, but it's more meant to be compiled in advance and be faster at startup.
It's claimed to be so, yes. Spring is a great project framework, just like Java, on the long run, right? But Java was never meant to start instantly, because Java, when Java was invented, there was no cloud.
There was no web.
There was no web even. Like there were, then it appeared, and then there were applets that were buried, like in the previous release in Java 25 or in Java 26 going to be like anyway. So applets have been around for a very, very long time, right? And Java was just not meant for this kind of work, but it's great. Its performance is absolutely amazing on the long run, because it has this dynamic performance optimization, the JIT compiler, all the goodies, right? But as we migrated to the cloud, the new problems arise and that we have to tackle somehow, right? So and there was
and I think there is an entire industry that relies on Java that's not going anywhere, right? Like mostly for banking industry, right? So and I think Java is mostly dominated by Java and .NET, right? Banking.
Yes. I mean, really, Java is not going anywhere. I mean, anybody can laugh hard at how old Java is, but it's going to survive all the other languages. Maybe
some people say it's the new COBOL, right? It's gonna be here.
Well, you know how much COBOL engineers actually earn?
They're well paid, yeah.
Yeah, I am sincerely considering learning COBOL.
You know that I started my career as a COBOL engineer. Like
No,
my first job
really?
was yeah.
Oh
So that,
my.
yeah. And then I migrated into Java, so I'm well aware of the COBOL.
You might want to reconsider because if you want to buy a house in Miami
Oh,
someday.
yeah. Yeah, I think technologies they evolve, right? I think Java, one of the biggest advantages of Java is that it doesn't rely on a single entity. Even though Oracle has been the guardian of Java since it bought Sun Microsystems, right, and has evolved Java in a wonderful way. I think it has done a great job evolving the language itself. We see more frequent releases, more modern features. So it has done a pretty good job doing that. But Java, I think Java never relied on a single entity to produce new things. And I think an example is the OJP, right? Like nobody told me to do OJP. Like, and nobody told people to do Spring. Nobody told people to do struts. So I think since mostly Spring, and since Tomcat, I think Tomcat and Spring were the big divisions or revolutionary. Because before we were very focused on the Java E, right, the enterprise edition,
Yeah.
and we were using that a lot with the enterprise application servers like WebLogic, WebSphere. But we started seeing many problems with that, like that you would build up an application for one, you couldn't move to another. And then is when Tomcat and Spring came about to kind of free everybody, from these ties and create a new world. And I think Java is very important and relevant because it allows you to do this. And my experience with OJP, being an open source project, is that the amount of people you find to help you, it's just, I don't think there is any language, any platform that you can do this. I would be very surprised if you just count the number of Java champions that already helped the project, or the Java user groups around the world that helped the project. So you find this gigantic community that is always producing things. Like I have people now in the community of OJP that are the creators of JTON, which is another open source project. The creators of Switcher API. So they come to help. Nobody told them to help. Nobody's paying them. And I find this ecosystem around Java and around open source. I think Java has it just has it's almost if it's an evolutionary system, almost like the evolution of species, but inside the technology, right? Because you have so many people trying so many new things, and then you get these wonderful things that comes out, like Spring. Spring was a wonderful thing, which turned into Spring Boot and really created a revolution, and it won this spotlight. And we at OJP, obviously, we look at these frameworks. We're compatible with all of them. And we partner up also with more traditional Java, Jakarta E, with Omnifish now being a partner of OJP. Because we want to attend the vast majority of people that use Java technologies, and make it a better solution for Java. I think that was missing in the market, so we're trying to fill that gap.
Which is just fabulous. But speaking of filling the gap, so you created OGP because you felt that something was lacking in other similar solutions, in other database proxies. So what was that? What does OGP offer?
Where do I start? There was a lot of things missing. So to be honest, this has been an idea since 2018. So for a few years, I waited for someone else to do it. But as nobody else took the job to do, I decided to start it myself. And now I'm not alone anymore. There is dozens of people helping. But the idea started with the problems we discussed here, right? Like, how do we manage connection pools in Java? Because that was an important thing for me. Because we usually have Java solutions and solutions that are for Java and for other things. And most proxies that existed, they are these generalist proxies, right? And they don't take advantage of all the capabilities we can take of Java if we build it in Java. So I think one of the first things I noticed was we didn't have a solution that was meant for Java. There was these proxies that you would be bound to one technology or one cloud. At the time I was looking at it, it was mostly technology, right? Like there was the AWS proxy. I think you had already the Oracle one. Popular, I mean, but the proxies were growing in popularity. So the freedom, I think, if we want to put in one word, I think the big driver is freedom, because I wanted a proxy that is not bound to a database, it's not bound to a cloud, it's focused on Java, and it leverages the years or decades that Java brings to the table in terms of the frameworks and tools that he created. And OJP merged together some of the best technologies Java produced in terms of accessing the database. We leverage the JDBC drivers, so we don't create new drivers to connect to the database. We use the native JDBC drivers inside the proxy. We deliver a new, the first and only, I think, JDBC Type 3 Java open source and free. It didn't exist before.
May I interrupt you here for a second, please, Rogerio? So when you say JDBC Type 3 driver, what do you mean? If somebody from our...
Good question. Let's explain that. So JDBC has types, right? And the first three types is that the first type that was created of JDBC was the JDBC it was an adapter. It didn't really connect to the database. So it connected to another protocol. I can't recall the name of the protocol. Apologies. I probably have it in my notes here. But in the beginning, JDBC was an adapter. So it used another protocol written in C or something else. So it had to translate things into that protocol. So it was more an adapter than actually a driver. So the JDBC Type 2 improved that. So now it could connect directly to the database without any adapting, not using another driver. So the JDBC became the driver that connects directly to the database and understands the database protocol. So that was the Type 2. And the Type 3 was a different architecture for the driver. So instead of the driver connecting directly to the database, it connects to a middleware. And the middleware can do many different things, right? So the specification of Type 3 is very broad. It just means that the JDBC driver doesn't connect directly to the database. It will connect to a middleware, which is in our OJP server, the proxy, right? But it could be some other middleware, something that does some other job, maybe validates security, or it can. The idea of the Type 3 is that you do a quality of service layer, right? So before you reach your database, it could be even for security, right? Just so you segregate better your networks, because you could have one network for your application, one for the proxy, one for the database, or the middleware. It doesn't necessarily need to be a proxy. So the Type 3 came to give this possibility, but we didn't really have an open source Type 3 JDBC driver before OJP. So it was something that the market didn't have.
I see. So, as if I understand correctly, OJP sits between the app and the database, and you basically don't have to change anything, well, not much in your configuration, right? So the application just sends the requests through the OJP, like as if it would send them directly to the database, right?
Correct. Yeah. One of the big things for us, because I'm mostly a Java developer, I think most of proxies, they were built by database people more, with more the database perspective on things. OJP is, because I'm a developer and most of the ideas, maybe they take a bit more the application side of things, and we made it very easy for the application, the Java application, to integrate with it. So basically what you need to do is you change your URL to point to OJP server, but you don't need a lot of extra parameters. You change your JDBC driver to use our driver, and basically you're good to go. There is a few other steps. Obviously, if you want to configure it here and there, for production purposes, you're going to need more than that. But just to get it running, that's about it. Like you change your URL to point. We use a OJP prefix, and that will tell where your OJP drive server or servers are. And you need to use our JDBC driver, OJP JDBC type 3 driver, because that's the guy that connects to the server. And that's the guy that decouples the connection management from your application. What that driver does is when you ask a connection, it doesn't really give you a connection. It gives you a handle that is, let's say, a passport to request a connection in the future, or a ticket to request a time with a connection in the future. So it's a voucher for a connection, let's say. So when your application gets that connection, it can do all the preparation for the query, but only when it sends that query is when we allocate a real connection to the database. And that little amount of time we save every time you're doing that, it counts in relation to how much you can do to the database. Because while you're creating the connection or setting up your parameters, maybe you are doing some logic before you actually execute the query. All that time in traditional JDBC implementations will hold a connection in the database. That connection could be used to do something else during that time. It's very small times, usually nanoseconds, maybe milliseconds. But again, at scale, all these nanoseconds, these microseconds matter, and we want to save them all. So I think that was an important aspect of when we were thinking about it. Later, actually, the load balancing and failover on the client was not an initial idea. But once we had the JDBC driver in hands, we thought, why not to use it to do client-side load balancing and failover? Because then we can eliminate the need to put anything in front of the proxy. And I think that was an evolution during our discussions and our conversations that came about. And we could save this extra round trip that most of the proxies require from the applications.
I see. So, and if something happens, if the proxy has to restart, or if the proxy exits, or we have the network jitter, what happens next? Like, what happens under failure? What's the failure mode for the proxy?
Yeah, for most proxies, the failure mode is that load balancer will transfer load to a healthy node, right? But things that we do differently, for example, when one of our OJP servers goes down, the remaining servers that are in the cluster, they get notified by the client, because again, we have the client, so we can use the client to transmit this health status of the cluster to the servers. They will notice, in an example, if we have 3 nodes, we recommend 3 as minimum for production purposes, right? If we have 3 nodes running OJP server and we set our connection pool to a maximum of 30 connections, apologies. What those 3 nodes will do is they're going to separate that maximum between them 3. So each one will have 10 connections maximum. But if one of them goes down, the cluster will understand, well, we lost a body here. So we need to compensate for that. So the remaining 2 will raise their maximum connections to 15 momentarily, right, until that node comes back up. And once it comes back up, they rebalance again and keep your maximum at around 30 connections. Obviously, during the failover, it can drop, right? And once the node came back, you can be a bit over 30. But in general terms, you always be around the 30 that you want the database. And that 30 is probably the best set for your database size, and probably a reduced size because you already saved some money in relation to the size of the database you're using. So the failover is very important for the failover to retry connections. And what we do in OJP is that, let's say, it failed to connect to a node, right? That node is dead. Something happened to that node. Maybe the cleaning person stepped on the network cable of the server. The node is not there anymore. What the app will do, your application is not going to even feel it. Like the JDBC driver will see that that node is unhealthy, we'll mark it as unhealthy, we'll stop sending you requests to that, and we'll route to the remaining healthy nodes. And we'll tell the remaining healthy nodes, look, this guy went down, so you need to rebalance your connection pools. So I think that gives you a peace of mind that if something goes wrong, it for you is transparent. Like it's not gonna, the application is not gonna fail, except if it's an in-flight transaction, right? If it's an in-flight transaction, the transaction is started and you didn't commit yet, then it will fail because if you have a transaction, we need to make it sticky to the server because it needs to be sticky to the connection, right? So it creates a pipe. Once you create the transaction, it creates a pipe directly to the database. That pipe is broken. You will see failures on transactions. Also, distributed transactions is the same, right? There is the ability in OJP. There is the ability of if you didn't start, if you didn't hit the start of the XA transaction, you can still move it to another server. But once it's started, like it's in-flight transaction, then you cannot recover. I don't think there is any proxy that can do that. But one of the main differences of OJP to other proxies is this ability to rebalance the remaining nodes. I never saw this anywhere else. We tried to do that in a way that we dreamed of. I think that was the dream, like why the proxy cannot adapt, like if the cluster is lost a node, why do I need to lose those 30 connections? Like, there was no technical reason for that. It's just that there was no solution to address that.
Exactly. So what would you recommend as the migration path, right? So we have right now several services. The database is overwhelmed, the connection pool is per pod, right? And everything's messy. So what are the next steps that the engineers, the developers should implement, right, to go through from messy to ordered and resilient?
I think this is the general suggestion I would give, not just for OJP if you're going for a proxy, but please do consider OJP if you're going for a proxy, because I think you're going to be surprised with the amount of things we're bringing to the table. The first step, I believe, is to migrate a smaller microservice, right? Like you get a smaller version of it, even though it's not the one that will benefit the most. It's usually the teams will be more comfortable doing less critical microservice, and a smaller one will take you less time to get it done. And it will increase your confidence in relation to, oh, that's how I manage OJP. You start getting used to the namings, like how it scale, how you can handle deployments. You're going to probably experiment like what we said, where are you going to deploy this OJP, which network. So you're going to find the best balance for yourself. About that, we are about to launch an ebook, a free ebook. It's going to be available soon. We're going to be advertising it soon. That's the first time I'm talking about it publicly. But
wow.
It's on the works. And you're going to talk about all these nuances. So you're going to be looking at the ebook. You're going to help you like to make this decision, like where to put OJP and etc. But to start small and starts with one microservice, test it locally in your machine, deploy to a test environment, start playing with it. That's the first step. Once you're confident with that, deploy that one in production, right? And that will give you the confidence of deploying the infrastructure in production. It should be very easy. We provide Docker images, right? So we provide Helm charts. So once you're familiar with this, you're probably well off into the position where you can start picking other microservices. And then as the team is already familiar with the structure, is very comfortable with how it's done, you start migrating other microservices. I think this is a strangling pattern. I think it's the best pattern for you to use, and start with the easiest possible scenario, like let's say a crude scenario, or the hello world scenario. That is just to ramp up your knowledge. But here at OJP, I don't know how other proxies do that. But for Java developers, because it's built by Java developers, we tried to make it as easy as possible, as simple as possible. and to not alter dramatically how Java applications operate and are written, to adopt OJP. And because it's our core public, right? We do it for Java developers first. We want to do it for other languages as well. OJP allows for that, but our first implementation, the current implementation, is fully focused on Java, and it's meant for to be easy for Java developers to adopt.
Cool. I already want this ebook. Please drop me a line when it's available. I'll be the first to grab that, because JDBC connection pooling and database proxies, that's a very fascinating topic. Rogerio, what tools, maybe profiling tools or observability tools, would you recommend adding, like pull measuring the pull metrics, doing some DB side telemetry, some proxy metrics? What kind of tools we can implement to actually see the improvements, to see the core problem, that the problem is in the misconfigured pools, and see the improvement after
That will
implementing?
all be in the ebook, but shortly. At OJP, we made an architectural decision, and you can see that those decisions in the architectural decision records in the GitHub repo. All the decisions, why we wrote it in Java, why we use gRPC. And one of the first decisions was to use OpenTelemetry, right? So the one good way to monitor things nowadays, and again, OpenTelemetry, as the name suggests, is an open technology for monitoring systems. So you can see metrics and traces and all in one place, all in one protocol. Before OpenTelemetry, it was sparse, like every provider would do it in its own way. So we are focusing, I cannot talk for other proxies, but we are focused on adopting more open solutions. So currently OJP exports telemetry through OpenTelemetry protocols, but we are allowing Prometheus to collect our metrics, but we are well prepared to do other types of connections to telemetry systems like Datadog or data analytics. That's in the plans to do direct. But also, like all these guys, they can read Prometheus. So that's why it was our first implementation. It ships already with OJP. And you can gather very important metrics in relation to all the gRPC. As OJP uses gRPC, so we export all those to Prometheus, and you could plot all that in a Grafana. Very nice chart. You can create triggers from that. You can see your average request rates, percentiles. With some work, we're gonna discuss that in a bit more detail in the book. There is a chapter only about telemetry. But that's the main thing. I think you need to be monitoring for error rates and latency. That's the two most important metrics you want to be looking at, because if your latencies are increasing, you're probably going into a problem, right? If they're never coming down, and error rates, obviously, like if it's already creating average error rates bigger than before, that's also a metric you're interested in. And so our commitment at OJP is to use open telemetry as our metrics and tracing solution, and to give more portability as well. So if you use OJP, you're not going to be bound to, let's say tomorrow OJP launches a monitoring tool that only works for OJP, right? That's not going to be the case. You can plug it into existing telemetry. That's something actually you want to look into proxies, like how do you monitor them? Like how can you get those metrics into systems that are not proprietary? I think that's a trade-off about what we were talking before is what I would call agnostic architecture, right? Like you're trying to do your architecture as more agnostic as possible. And one element is this, like how do you see your telemetry? Like I think open telemetry is the de facto standard. Like Kubernetes became the de facto standard for orchestration. And there are good things to use together in terms of getting more freedom. And OJP obviously now is in the pot, because we have this mentality, like we don't want to catch people by forcing them to stay with us. We want to deliver something that they can use freely, and if they want to move away from it, they can move away easily. That is not a binding product that goes in line with the idea of Kubernetes, of open telemetry. That's why it's Open J Proxy. It's open to be used and shared. And if you don't want to use it anymore, it shouldn't be difficult to go out.
That's fascinating. I mean, and I think we really need a live stream later someday on OpenTelemetry and on doing all that metrics stuff and profiling stuff for databases. I mean, that's a very exciting topic. Well, Rogerio, thank you so much. Friends, if you have any questions, please post them in the chat. And meanwhile, I'm posting into the chat as well the link to the Open J Proxy project, right? So check it out. Course, they have a very nice website and the GitHub repo, right? So it will get you started. And also, I have recently made a video on ways to configure JDBC connection pools, and also it touches a little bit upon the topic why they might break, right? And you can check it out as well, this video. I'm posting the link too. So yeah, if you have any other questions, we are going to be here for a couple of more minutes. Rogerio, what are the next big plans for OJP?
The very first one is the ebook, right? So it's coming out
Yeah.
right now. Probably these next few days we're going to be announcing it. I'll send you first hand the link to it.
Thank you.
Another thing that is in the works at this very moment, we are doing an experimental attempt to integrate OJP with Apache Calcite. And Apache Calcite is a Java library that is used already by Apache Hive, for example, and many other products in open source projects, not just open source. But Apache Calcite, it delivers the ability of checking if a query is well written. That's one of the things you can do. First, you can check if it's syntactically correct. So you don't need to send the query to the database to know that it's incorrectly written. That's another thing you remove. That's why we are interested on investigating Calcite. And the other thing it does, it can improve the query actually. So let's say you have a big query like coming from a legacy system that does the joins in the most poor possible way. Or if it's coming from, there is some analytics tools that allow the user to create the joins, right? And maybe the user is not a DBA or not a developer, and he just joins the things in the way he wants to receive the data. So it's not a great way to join or to subquery things. What Calcite does, or what we are trying to use, is the ability to improve these queries. So we don't think you should be aiming to have it in production, but even if you do, so if you receive a bad query, it will be translated into a good query before it gets sent to the database. Yeah. And again, that's only possible because we're a Java project. Because Apache Calcite is a Java library. So if we were written in C or some other language, we wouldn't be able to leverage the ability of Calcite. We do it with many other things, like we use HICRCP as a connection pool, DBCP as a secondary option for a connection pool. Talking about that, one big thing that's coming out is the SPI, Service Provider Interfaces. So you're going to be able to put a new pool yourself. Like we created an interface. If you want to, let's say you don't want to use HICRCP, you don't want to use DBCP. You want to use Oracle, for example, Oracle UCP, which is a growing popularity connection pool. You can implement our SPI, and we have actually engineers of Google looking into this and taking a look, see if they can contribute something in relation to the SPIs to integrate OJP with Oracle UCP or any other connection pool. So we are looking to make it even more free. Like if you don't want to use the things we bundled it with, you can create your own things. You can create your own or put your own connection pool. Let's say your systems run forever with C3P0 or some other connection pool. You want to keep that. It will not be difficult to move away from HICRCP, DBCP, which are the ones we provide, and the one that we provide for XA, because we created a connection pool ourselves for distributed transactions. That's another full subject, but you can move away if you want. I think we're moving more and more towards freedom. Telemetry is another thing we need to work into improving. We want to improve the data in telemetry we explore. And I think those are the things that are coming up this year. Early this year is the SPI's D-book. And soon after CalSite, we should have a call if we want to use it or not, and why. I think that will be very interesting for the community as well, because maybe it's not for us, maybe it's being, I would be surprised if that's the outcome, but we are still experimenting with it. So still in the works in relation to how we're going to use it, like how we're going to configure it. Because there is all sorts, like, do you want to do it inline? Do you want to do it offline? Do you want to, because if you do it inline, you delay the query to the database. So we're trying to work out what's the best way to deliver this inside the OJP in a way that people will benefit from it.
That's nice. Really fascinating. I've taken a note of this Apache CalSite. I'll check it out. Yeah, because I think that might be very useful, because slow queries still stay slow queries, right? Maybe the database proxy can handle this load, right, and somehow manipulate that so that your database is not overwhelmed, but the bad query still stays the bad query, right? And it will be better to improve it, right, to rewrite it. And it's often the problem with the Hibernate, right, because it has the implementation of SQL, and then you get the nasty N+1 surprises or whatever, right? So SQL is important, but that is, I guess, the topic for another webinar, right? So
yeah, I think that's what we would like Hibernate to do, but it was never its job to do, right? Like improving SQL for us.
No, of course. So Hibernate is a great tool. It's a great tool for its own specific use cases, right? So I don't think that there's any bad or good approach, right? So it's just that every tool is for some specific approach, and Hibernate is good for if you want to write some simple CRUD. If you just have like a prototype or a small lab, then yeah, that might be okay. And then it has some features that may be lacking in other approaches. But then there's the SQL first, like there's JDBC, there's Juke, right? An amazing project that helps you tailor your SQL if you need that, right? And you can combine them. In one project, you can use Hibernate for CRUD, right? And Juke, for example, or JDBC for complex analytics. So mix and match, kind of like that.
Yeah, that's what I would find the most common thing. Like, I think for the vast majority of use cases, you're probably going to be fine with Hibernate. And then your few queries that need that special function that only exists in Oracle or in SQL Server or Postgres, then you're going to use a native query or a different library to do that. I think it's important to acknowledge that it's not a single solution that fits all. And I think especially in relation to the database, I think you need to look at what's your scenarios and which tools fit with your expectations. Like we talked before, I think we mentioned that before, like a lot of systems probably didn't have to be microservices. They could have been well off being just big monoliths to this day. But maybe there is also this overexcitement about new technologies that people get into, and myself included, right? When microservices came about, I think we were all super, super excited.
Yeah.
But we ended up migrating more things than we should to microservice.
Yeah.
I think looking back, maybe a few solutions that were migrated didn't have to be migrated to
Exactly.
But that's a learning curve, right? Like now looking back is easy to make that statement, but once you're in the storm with new technology and you're trying to do the best for your system, you might make a call to migrate when later you figure out like the cost of migrating overcame the cost of actually improving your legacy system to a point where you would be able to tolerate the load you needed.
Exactly. Yeah, sometimes the microservices are an absolute overkill, right? Just as we mentioned in the beginning of the talk. Uh,
Yeah.
right. So to sum up, Rogerio, how would you summarize the go-to solution for chasing away the JDBC connection pool problem? So how would we summarize the steps to remedy the situation?
Yeah, I think the first step is to acknowledge it, right? Like an alcoholic, like first acknowledge that you have the problem. That's the first step, because I think sometimes people go with the easy solution, right? Like, oh, we can just put another node in the database
Yeah.
or make a database bigger. But is that really the solution? I don't think it is. I think the solution is to look deeper into the problem and look for ways to avoid over provisioning things. I'm very keen to make things more efficient. So acknowledging that there is a problem with microservices and traditional connection pools is the first step. Acknowledging that that problem is not a problem everywhere. Like we said before, depending on the size of your system, it might not be a problem. So first, map where you are. And if you see that, because maybe you are already far off, maybe you already saw your database going down or becoming super slow. If you're at that stage, then you're in urgency of finding a solution. I think a good solution to look into is the proxy, using a database proxy. We offer a database proxy, but in general, is a good solution for the scenarios where you need large scalability and you don't want to over provision resources. You want to keep your costs at a minimum, and you want to be free. I think those are the things we try to address, the things that I care the most about. And the way to prevent modern microservices from killing your JDBC connection pool is to look first what is exactly your situation. Where are you growing to? And how likely, for example, is for you to move cloud providers? Because maybe you are all into one cloud provider. It's easier for you to provision the proxy there. I don't recommend. My recommendation will always be to have more freedom and go with solutions that give you more freedom. And so to summarize all that, I would say go for Kubernetes always, for open telemetry, for the open standards, Open J Proxy, and that will allow you to have more freedom of decision of providers in the future, and I think that's important strategically and technically, because if you think about, like, the open solutions tend to win. Like we can mention Linux won, like, right, the operational system battle.
Yeah.
Kubernetes won. So you see that you have proprietary solutions that they last for a while. It's like empires, the rise and fall of empires. But you see that open source solutions tend to outlast even the best proprietary solutions in the long run. And we saw it with operational systems. We saw it now with orchestrators. We saw it with application servers, right? Tomcat won. So it didn't. Nobody could say that it would win when it came out, but it did, because it was open. Many people contributed to it, and it became better than previous solutions. So summarizing everything is like, look for freedom. I think that's my phrase to go.
That's a great inspiration. Yeah, I love that. Well, thank you so much, Rogerio, for this very inspiring talk. Very interesting talk. Friends, if you still have any questions, you can find me or Rogerio on LinkedIn or on Twitter. It will be Twitter forever for me. I'm too old for that shit. Yeah, and yeah, have a chat. Ask anything, right? And we are going to be there to help you, to answer your questions. Thank you so much for coming, for being with us tonight. I'm Catherine Edelweiss, developer advocate at Bellsoft, and today in the studio was with me Rogerio Robetti, the founder of Open J Proxy, open source database proxy. Thank you again, Rogerio. Thank you, friends, and until next time.
Thank you
Bye-bye.
very much. Have a good evening. Bye bye.